Connecting Scientists. Thank you, Janet. I keep forgetting that. I'd like to welcome you all to Connecting Scientists with Middle and High School Educators. This series is brought to you by the Alaska Natural Resource and Outdoor Education Association in partnership with the Alaska Cooperative Extension Service, Project Learning Tree, the Alaska Department of Fish and Game, and the Arctic Research Consortium of the United States, or ARCIS. This is Kathy Rezebeck again today, and I will be your facilitator. I'd like to thank ARCIS particularly because they are contributing the use of the Blackboard Collaborate platform, and you will see Janet Warburton, who is my logistics backup. She has been teaching me, and so we hope all goes well, and I feel very comfortable now that we've got one under our belt, and this is number 2. I'm learning, and I'm sure you will get more comfortable with this platform as well. So this is the second in our series of 5 webinars. Today's webinar is being presented by Sierra Doherty with the Alaska Department of Fish and Game, and the topic is Wildlife Outside Your Back Door. All the sessions, again, will be on every other Wednesday at 4 o'clock p.m. I'd like to ask those of you taking this for credit to stick around just a couple of minutes at the end of the presentation for a couple of announcements. So we are interested in making this interactive. Sierra is interested in hearing your questions. And if you have a question during the presentation, write it down in the chat box. If the question is, if I'm able to interrupt Sierra at an appropriate time, we'll go ahead and ask the question at that time. If not, at the end of the presentation, all the questions will be answered. Just to remind you all, in order for you to talk, you need to press the talk button and then talk, and that is in the upper left-hand corner of your screen. When you finish asking your question, then you must unpress the talk button so that Sierra can answer. At the end of the presentation, if there are multiple questions, we'll go ahead and just use the hands up, raise your hand feature, which you will see there right above the list of participants. It's the third one, well actually the second one from the right, the hands up, raise your hand button, and then I will know that you have a question through chat. I'll see that come up through chat. So today, we're going to hear from Sierra Doherty, again with the Alaska Department of Fish and Game. Sierra is originally from Colorado and moved to Alaska to pursue degrees in environmental science and outdoor or environmental education. After her graduate studies, Sierra worked at the Alaska Pacific University and then for the Palmer Soil and Water Conservation District, coordinating programs that get youth outdoors. She is now the education specialist with the Division of Wildlife at Fish and Game. She loves to ski, kayak, and sing in her free time. But before I turn it over to Sierra, I thought it would be a good idea, since we are actually going to be hearing from one another every other week, to get to know a little bit about one another, at least more so than we did 2 weeks ago. And so what I'd like to do is simply call on you via the list of participants. And before Sierra begins, I'd like you to just tell everybody who you are and what you do and where you are physically located. And I think that will help us all get better acquainted. So I'd like to start with Beth Trowbridge, please. Again, you must press the talk button. Well, let's say Beth, and let's go down to Emily Carson. Emily? Once again, what we're doing is we're going through each participant and asking you, when I call out your name, to simply to press the talk button. Tell us what you do, if you're a student, if you work for someone, what you do, and then where you are physically located. So we'll get back to Beth and Emily. Let's go on to Helen.
Hi, can you hear me?
Yes, Helen, go right ahead.
Okay. I am in NOATAC, and I teach 5th and 6th grade here. And this is my first year in NOATAC. What else do you want me to tell you about?
That's perfect, Helen. Thank you. Welcome. Let's move on to, let's give Beth Trowbridge another opportunity here. Beth, can you press the talk button? Okay. Let's give Emily one more opportunity. Emily, can you press the talk button? Okay. Beth and Emily can introduce themselves in the chat section, so we'll watch for their introduction. Let's move on to Kristen Romanoff, please. Kristen, go ahead and press the talk button and introduce yourself.
I'm Kristen Romanoff, and
we can hear you.
Oh, you can? Oh, good. Hi, Kathy. I'm the Education and Outreach Specialist with, well, I'm actually the coordinator. I work alongside Sierra, and I live in Juneau, Alaska, and I'm very much interested in learning about this webinar series and in our outreach efforts. This is a new approach for us in doing professional development with teachers. So I'm excited to see it all firsthand and learn about it.
Great, thank you, Kristen. Let's move on to Lyle Milkerson. Lyle, go ahead and press the talk button.
Hi, my name is Lyle Milkerson. I teach math and science for grades 6 through 12 in Kivalina, Alaska. Thank you.
Thank you, Lyle. Let's move on to Meg Burgett.
Hello, this is Meg Burgett. I was with you guys 2 weeks ago. I'm the Project Learning Tree Coordinator, and I'm based here in Palmer, Alaska. And it's so nice to hear voices to connect to the names.
Yes, it is nice. Let's move on to Russ Hall. Russ, go ahead and press the talk button and just quickly introduce yourself. Oh, he's on chat there. He's at the Eagle River Nature Center, and he's the founder and former executive director of Wilderness International Youth Conservation Corps based in Oregon. Welcome, Russ. Shannon, would you like to try introducing yourself by pressing the talk button?
Sure. So my name is Shannon. I live in Fairbanks. I am in high school. I'm a senior, and I'm an Envirofon student. I was on the last call. So.
Yes, I recognize your name. Welcome again, Shannon. So I think we have given everyone an opportunity to introduce themselves either by voice or via the chat. And so what I'd like to do is now turn it over to Sierra Doherty, who is today's speaker. Vera?
Hi, thank you everybody for introducing yourselves. It's nice to hear your voices and know where you're coming from, particularly because this is not face-to-face. It's good to know that you're out there and you're real. What we've been hearing through some of the professional development that we've delivered through Alaska Department of Fish and Game is that teachers want more content. And that's kind of what sparked the interest in this webinar series to offer, from the science perspective, the topics in forestry and aquatic ecology and wildlife and so forth. So thanks for joining us today. Thank you, Kathy. As Kathy mentioned, I'm the education specialist in the wildlife division at the Department of Fish and Game. And my position is fairly unique in this department. Rather than specializing on one task or one wildlife species, my role is one of a generalist. So I learn about what other biologists do, and I share that information with the public through the creation of newsletters and brochures. I visit classrooms, give wildlife safety talks, and partner with other agencies to hold teacher workshops just like this. The other jobs at Fish and Game include, and this might be of particular interest for some of the students out there, wildlife technicians and research biologists. They work in the field quite a bit. There are management biologists who perform wildlife counts and deal with regulations and work directly with the public. We also have biometricians, GIS specialists, information officers, and administrative staff. And the picture in the upper right corner in the airplane, that's me doing a moose survey as an observer, so you can put a face to the voice. Okay, Kathy? All right, so today I'd like to give you an overview of important concepts that wildlife biologists must know and consider to do their work. First, they have to know a thing or two about wildlife species, which call Alaska home. So in this presentation, I'll highlight a few species as we go over habitat requirements, define biodiversity, explore concepts of population dynamics, and investigate adaptations by looking at physical and behavioral characteristics. And since this is a webinar, this presentation will be content heavy, but Kathy emailed you along with the instructions to participate in this webinar an activity resource guide. And that contains lesson plans that integrate the content I'll be talking about today. And most of the lessons come straight out of the Alaska Wildlife Curriculum developed by Alaska Department of Fish and Game. And for now, don't worry about looking through your packet and trying to figure out what the lessons are. You can take a look at them later and integrate them in your classrooms, but I will point them out when the time comes in the PowerPoint. And there's a ton to cover today, so I'm just going to get rolling here. I won't be looking at the comments too much, so again, if Kathy wants to interrupt at kind of breaking points to address some of the questions. Otherwise, hopefully I'll manage to cover some of the questions you have and we can discuss at the end. I anticipate using the full hour to the max. So next slide, please. All right, now you can type in some answers in the chat box. I want to try to make this a little bit more interactive. Okay, habitat. Wildlife and all living things need 4 things to survive. Type in what are they? What are the 4 things wildlife needs to survive in all living things? I see bubbles going off, but I don't see any answers in the chat box. I'll keep going here just for time's sake, but I'm sure you've got them down in your head. Food.
Vera?
Yes.
We are seeing them in my chat box. Rose has food, Beth has water, Lyle has food, shelter, water, space.
Yay! Perfect. Good job, team.
Shannon and Helen have them all too.
All right, excellent group. That's wonderful. You've all got 4 stars. Food, water, shelter, space. And they need to roam within a range that's right for them. So sometimes you'll hear this called a suitable arrangement. So the environment that meets all of these needs of an animal is called its habitat. But it's different for each species. And if we go to the next slide, I'll give you some examples. So the habitat of a red squirrel, it's a spruce forest, a place where trees provide plentiful seeds to eat, hiding spaces to escape predators, and nesting areas to raise their young. But some wildlife use multiple habitats, either daily or on a seasonal basis, like the omnivore brown bear, which will dine on roots, sedges in the springtime. And of course, once the salmon swim into our nearby streams from the ocean, they'll walk right past those sedges to go to that high-protein meal. Now, when the salmon have spawned and died and the early fall, the bear is going to go inland and gorge itself on berries or whatever other food source. So the key here to understanding habitat and also knowing where to find animals is to look at each animal's specific needs and where in nature those needs are met. Okay, next. And no matter where you live in the state, Alaska is rich with wildlife. And there's quite the diversity of species from southeast Alaska to the northern interior. So what exactly is biodiversity? We hear that word a lot. Well, it's a measure of the variety and number of different living things and their ecosystems. So this could be measured at different scales, whether you're talking a local, regional, or even on a global scale. Scientists measure biodiversity. They do two things. One, they identify and count the number of different species. And two, they count the number of individuals of each species. But why do we care? For one thing, habitats with a greater variety of plants and animal species are healthier and more stable, right? So if a certain type of plant becomes infected and dies out, the other plant species will live on and continue to provide habitat components for the wildlife in that area. Secondly, changes in the distribution and abundance of wildlife populations may be useful in indicating more widespread changes in environmental conditions. I'm wondering if you all can help me think of an example in the Arctic.
Should they type it into their chat?
Either way, you could type it into your chat, or you can raise your hand and Kathy can call on you to talk. So again, what are distribution and abundance of wildlife populations? What's an example of that indicating a larger change in environmental conditions? See some typing going on. Okay, changes in seal populations. There's a lot of the populations that in the Arctic that also coincide with changes in sea ice. So seals and also the iconic polar bear is an indicator of where its distribution and range is, could indicate a larger sea ice distribution and therefore changes in climate change. Okay, next slide. So
here, there was another one, an example by Russ, drop-in and dull sheep populations.
Okay, do you want to talk, if you can, Russ, about that?
Are you able to hear me now? Good.
Yes, we can.
I got my mic working. Yeah, it was just, there's a lot of discussion going on within the Department of Fish and Game and the advisory councils about the reduction or the drop in the wild sheep populations and making adjustments in the seasons. So I read an article in the newspaper about that, and I just found it an interesting topic.
Thank you, Russ. Yes, it is a hot topic, and the Board of Game meetings are going on right now. So just as a side note, if folks want to tune in a lot of the public commentary was this past weekend, but yes, changes in wildlife populations could attribute to many variables, including environmental conditions. And maintenance of the biodiversity means maintaining those populations of our diverse wildlife and our habitats. So we know that animal populations change over time. And they do this for a number of reasons, because of predators, because of starvation, hunting plays a role, disease, just plain old accidents, and of course extreme weather challenges. They change because of old age, because of loss of habitat. Populations lose animals also because they emigrate, move away, or they gain others from immigrating into the area. So the relationship between predator and prey species is very important to understanding population dynamics. Certain species display this cyclical pattern of growth and decline, and the lynx and the snowshoe hare populations in Alaska are a classic example of this cycle. Among larger mammals, moose and wolves also go through peaks and valleys of abundance, with each species population size dependent on the other. But wildlife that have a diversified diet, they tend to have a less dramatic swing up and down. So again, that brown bear that we used as an example earlier, they eat a variety of foods and they can diversify when one food's in short supply. So populations of tolerant species tend to be more stable and stabilize at a certain level, while other species like the lynx and the hare that have a very specialized diet, they fluctuate widely. Next. Predators they often limit the population growth of the animals that they eat, and then the prey population in turn, of course, limit the size of the predator population if they're the only source of food available. And of course, if the prey is an herbivore, then plants can also affect this relationship. And the star on the slide indicates an activity in your packet, and the first one is called Predator-Prey Predicaments. And this is a great lesson to get your students up and out of their chairs and doing something active, but also recording the data and this game that they're playing over a series of years and using some mathematics to illustrate the theory that the lynx population determines the hare population. And you can use any predator-prey relationship that you want. But as the number of hares increase, so do the number of lynx that survive and eat them. But soon you'll see there's too many lynx for the number of hares, and the lynx basically eat away their favorite food until they too suffer a population decline. But then the hare population can grow again. And in reality, usually this cycles between 8 and 11 years, and usually the hares will peak, and then the lynx are right after them by about 2 years later. And scientists have noted that when prey is abundant, there's a high percentage of 1-year-old female lynx that produce kittens, most of which survive. But when the prey is scarce, very few yearlings breed, and the overall number of breeding adults declines, and there's fewer kittens that survive into the winter. Next. So every population has a maximum size it can reach before the species exceeds the available habitat. This is called the carrying capacity of an area. It's basically the ceiling for the population. Numbers may briefly soar past the ceiling under favorable conditions, like if there's a really mild winter and there's lots of food. This could cause a population explosion. So when life's easy and there's better access to nutrition, the animals are going to be in better health. When they're in better health, we see increased pregnancy rates and increased recruitment rates. That is the number of young that are born and recruited into the population. And there's a pretty neat adaptation that bears, weasels, and bats even display. It's called delayed implantation. Some of you may have heard of it. Basically, the animal breeds, and the egg is fertilized, but the ova isn't actually implanted into the uterus until much later in the fall, or depending on the life cycle of the animal, to see if that animal has enough body fat to successfully carry the pregnancy. Of course, populations of herbivores such as deer and caribou may crash quickly if they exceed that carrying capacity. And this is because they can damage or kill their plant food sources through heavy browsing and grazing. The heavily browsed lichens and shrubs can take years to recover sometimes. And herbivores populations that have crashed are limited while their food supplies recover. So in this situation, the animals actually reduce their overall carrying capacity of that habitat temporarily. Everybody good with that? We can switch slides. So something that keeps a population of animals from increasing is called a limiting factor. Can you think of a limiting factor, something that keeps an animal population from increasing? You can type it in the chat box, please.
Sarah, can you see them come in?
I do. Ding, ding, ding. Excellent. Good. So you've nailed all the elements of habitat, and those are, if it could be a shortage of food, water, shelter, or space, that's obviously a limiting factor. I see decrease in habitat loss, absolutely. This could also be disease or predation, climatic conditions, pollution, accidents again. So just remember, limiting factors affect a habitat's carrying capacity. Here's another example. The availability of willow browse is a limiting factor for moose. More moose cows have twins versus singletons that survived their first winter in areas where willows are abundant. And wildlife biologists use what they call twinning rates as an indicator of a population's health or overall condition. Next. Another activity in the resource guide is called How Many Bears? And this activity illustrates carrying capacity and limiting factors, and the students compete by gathering different types of food within their habitat, and then they enter nutritional values without knowing what they're gathering in the beginning into an equation, and then they see if they survive the winter. So that one's a lot of fun. It requires making up some cards, but those are available again in the Alaska Wildlife Curricula. Okay, next. So one of the main jobs that wildlife managers at Fish and Game do is to track the ups and downs of these wildlife populations and determine the cause of the increase and decreases. And they do this because Alaska wildlife is managed on the principle of sustaining human uses of wildlife into the future. So when wildlife managers study population of animals rather than individual animals, they track the changes in abundance, and they follow these steps. So one, they need to determine the boundaries in order to know which animals are part of the same population before they can study how those populations change. They also need to know the best time of year to see and count the animals, and that varies depending on what species they're surveying. And then they decide what equipment makes the most sense. So are they going to do an aerial census, fly over it and take photographs? Or will they use telemetry equipment? And then finally, they're going to need to count those animals within those boundaries over years to detect changes and trends. A little note on telemetry equipment. This includes GIS and satellite collars that are placed on an individual animal. You know, they go down and collar animals, and then they fly over at a later date with observers, and the observers and pilots are recording the numbers of animals that are seen, and then also the number of animals that are wearing collars. With telemetry receivers, another biologist can fly over the surveyed area again to see if any of those collared animals were missed. And in that way, these data are put into statistical models to estimate the total population. Okay, next. I've included a photograph that looks just like this in your packet. It's an aerial census photograph, and this is one subgroup of a larger population. And what you'll need is print off as many photographs per person or per 2 students, and use a laminate page on top of it so they can mark with a dry erase marker or wet erase marker, and they'll actually mark each individual animal. And a good suggestion is making some smaller groups within the group that you see on the photograph. That makes counting more manageable. One fun thing to do is have your students just guess, just off the cuff, how many, without giving them much time, how many caribou do you think are in this photograph? And I think you'll be surprised. A lot of times we really underestimate the number. So regarding 200, okay. Yeah, you can make your guesses. I think, let's see, I have the number written down here. So while you're thinking about that, I'm going to talk a little bit more about doing these surveys. So caribou, as an example, the herds, they may spread out over tens of thousands of square miles during the winter. So where does one caribou population end and another begin? We talked about the boundaries. Well, fortunately for biologists, caribou herds form large aggregations after they calve. They come together to avoid predators and bugs like mosquitoes and warbleflies. And they gather in the high mountains or the sea coast where there's a lot of wind and it's cool. Well, this is an advantage to the biologists because we can fly over then and count each animal at this time of year. Not all wildlife species come together in groups at certain times of year, though, and many animals are hard to see during a survey, like moose in a dense stand of spruce trees. It might be really difficult to see them in an airplane, so if the scientists, the biologists will wait until late fall after snow falls and there's a white carpet, and then you can start seeing tracks, and those black blobs start to really contrast with the snow. So again, knowing animals' life cycle is really so important in these survey methods. Okay, so let's see, I'm going to scan down to see your comments and guesses on the numbers. A PDF presentation, okay. Russ,
Here, I'll take care of that if you want to just, we've got a bunch of estimates here of the numbers.
Oh, there they are. Got it.
So the guesses were 150, 200, 245, and 260. Kira, can you hear me? I have a feeling we lost her by phone. I'm sure she'll call back. Let's hang in there for a little while. Oh, we have another guess, 300. If we wait long enough, you all can sit there and count them. Oh, there was a question. Here comes the again. I'm sorry, Kira. I think your phone call was dropped, but I'm glad you're back.
Hi, me too. Okay, where were we? We were on guesses of caribou, and I saw numbers around 200 to 300. The correct answer is 348 caribou in that photograph. So pretty good, yeah, and generally people do underestimate. So, holy cow, Shannon says. Okay, let's continue on. I'm going to shift gears a little bit here to keep the pace going. And I wanted to talk a little bit about skulls, and I'm just going to mention a few things about it, primarily for those students and teachers that are preparing for the Envirothon, but it's also interesting in general to make some overall observations when looking at skulls. For one thing, the placement of orbits, which are those eye sockets. In carnivores, so we have a lynx on the left and a snowshoe hare on the right. In carnivores, the orbits face forward on the skull, giving them what's called binocular vision, so they see with both eyes. Forward-facing eyes give carnivores depth perception and the ability to judge distance. This is critical to their ability to catch prey. Herbivores have orbits located on the sides of their skull so they can see predators coming from all directions. Herbivores have what's called monocular vision, so they see a different image in each eye. Each eye can see approximately 180 degrees, and for some herbivores such as deer or moose, the orbits are kind of angled slightly forward to give them what's called partial binocular vision. But anyway, the size of an animal's orbits or eye sockets correspond to the sharpness of their eyesight. So the larger the orbit, the better the eyesight. The lynx most acute sense is vision, and proportionately it has the largest orbits of all Alaska land mammals. Okay? Teeth. So on the left we have a wolf, and on the right we've got a beaver. Teeth tell us what an animal eats, whether it's carnivore, herbivore, or omnivore. Carnivore teeth are specialized for tearing and shearing. They have three primary types. The incisors are the front teeth. They're relatively small and less developed than the canines, and they're used for grooming and fine nipping on tender foods. Then we've got the canines. Those big teeth, they're also called cuspids or eye teeth. They're very sharp. They're long for piercing and holding down their prey. And of course, then the cheek teeth, which consist of the premolars and the molars, and they're sharp for tearing and cutting. So the cheek teeth exhibit the greatest amount of specialization, indicating what the animal eats. In carnivores, some of the upper premolars overlap with their lower teeth, and they're known as carnassial teeth. And carnassials act like shearing scissors. Some herbivores, such as rodents and hares, they don't have canines at all. Other herbivores, such as hoofed animals, which are also called ungulates, have canines that are not distinguishable from their incisors. But in all herbivores, the incisors are well developed to cut vegetation, and there's this wide space called a diastema between the incisors and the cheek teeth. And this big gap that you can see in the beaver there, that gap allows for food items to be easily carried and manipulated. In some rodents like the beaver, if you didn't know, the beaver is the largest rodent, the lips close around the diastema, allowing the animal to gnaw with their incisors while they're keeping the dirt and wood chips and the water out of the mouth. And rodents too, they have those chisel-like incisors, and it's a fun fact to share with your students. They're subject to tremendous wear, and their growth is continuous. They grow their whole life. So if the teeth are underused, they'll grow beyond their lower jaw. Next slide.
Sierra, it is 4:39 and you are on slide 19.
Yeah, we kind of got a late start there. That's okay. All right, so this is an Alaska ecology card. The department has these cards. They talk about all the context of the animal's environment, and they're handy references to talk about habitat and food requirements. And the reason I'm showing them to you is because I've integrated a few to make this a little bit more interactive. I'll just have you type in the answers to some of my questions. So it's quiz time. Let's go to the next slide. Okay, so for example, I just pulled the mammals in this case, so there's a hint. So this is a medium-sized mammal with long incisors and webbed feet. It's got a long, flat tail. As soon as you know that answer, go ahead and type it into the chat box. It lives in slow-moving streams. It's the beaver. Good job, Lyle. Next slide. Okay, so the beaver is so well adapted. While I talk about it a little bit, go ahead and write in what adaptations does a beaver have that help it live in its environment and do what it needs to do to survive. All living and non-living things together make up an ecosystem. There are many ways in which living things are finally adapted to survive and thrive in that ecosystem, filling their niche. And I don't see any answers yet, but for one thing, beavers have water-repellent guard hairs, and they have that warm, soft underfur, keep them comfortable in lots of temperatures. Webbed feet, big black tail that is used as a rudder. It also has nictitating membranes to protect its eyes. Okay, let's continue on to the next slide. So let's talk a little bit more about adaptations. And I've thrown in a few other ecology cards to, again, make it more interactive. So when you see an ecology card, go ahead and the first person to, well, everyone can guess what the animal might be. So how exactly do animals survive up here in the cold Alaska environment? Next. There are three main ways. Migration is an adaptation for avoiding the worst and enjoying the best different geographic regions have to offer. Shorebirds, they migrate thousands of miles north and south. Migration routes are known as flyways. But ptarmigan, who stay in Alaska, they migrate from tundra regions and they winter in low alpine tundra and forests, sometimes only a few miles away, and there have been some birds that have seen biologists attract 100 miles from the Northbrook Range to the southern side. And of course, caribou we talked about as well. Okay, next. Here's a pretty fun website that the USGS put together, the U.S. Geological Survey, called Wandering Wildlife. It's for educators to teach about migrating animals that live in Alaska, at least for a part of the year that is, and it tells you a thing or two about radio telemetry and how that works. So for brevity, let's say you wanted to learn about the brant and its migration. So you're going to click on the brant. Next slide. And you want to know why this study is important, so you click on that button and it'll tell you that researchers in US, Canada, and Mexico work together to better understand brant's habitat during their staging and overwintering. And in Isenbeck Lagoon, which is where the 7879 individual is located, it has the largest eelgrass bed in the world, and that's their primary food. But way down, right about where 7725 is, down in Baja, Mexico, that's their wintering habitat. So say you want to click on an individual, you choose 7879. Next slide. You're going to see this, and there's a video. You can push play, and the video starts July 1st, and you watch 7879 begin its long migration over the Pacific. And the migration starts on November 1st, and it arrives way down Baja, Mexico on November 4th. So really quite an amazing flyover. Okay, so have fun with that website. It's up on the slide there. Next. We can go ahead and advance. Okay, so the second adaptation is hibernation. And this little guy is the Arctic ground squirrel, and it's just an amazing hibernator. Humans, we die if our body temperatures drop below 90 degrees, even for a short time. However, during winter hibernation, this Arctic ground squirrel burrows 3 feet deep, and it enters a state of torpor, T-O-R-P-O-R, which is a decreased conscious state in which the metabolic rate and body temperature are drastically lowered for up to 3 weeks at a time. Their body temperature drops from 99 degrees to as cold as 27 degrees Fahrenheit, below freezing. But between the states of torpor, they arouse and they'll either shiver really hard or they'll use stored fat to bring their body temps back up. And this rewarming period usually lasts about 1 or 2 days, and then they return into their deep torpor state to conserve energy. Can you type in other animals that hibernate through the Alaska winter? And we can advance to the next slide to give ourselves a hint. Okay, wood frogs, yes, or frogs in general. Thanks, Shannon. Bears, yep, bears are hibernators, although they don't reduce their conscious state into a subconscious, into a torpor. Bats, very good. Okay, so you must be reading this ecology card. This mammal has 4 legs modified to form membranous wings. It has key eyesight. It lives in the forest. It eats mosquitoes. We can advance. This is the little brown bat. It only weighs 5 grams. It's half the size of a chickadee. And it overwinters by hanging upside down in trees, but it's also found in shelters, in house eaves or abandoned buildings. Of the bat species located in Alaska, the little brown bat is the most common and widespread. And
if I could interrupt you, Helen wanted to backtrack slightly. The question is, what does the Arctic ground squirrel do about the growth of those long claws when he wakes up?
Certainly needs to go see get a pedicure, I would say. Yes, well, if you can imagine that they burrow 3 feet deep, they certainly use those claws quite a bit. So it would be interesting knowing how fast they're worn down after their long winter's nap. Yes, and Jan says they're digging themselves out. Okay. I think that's enough for the little brown bat. We can keep going here.
Are you there?
Hi there. Okay, sorry about that. Okay, so yeah, if you do not migrate out of town and you're not sleeping through the cold, harsh winter, you're going to have to develop physical and behavioral characteristics to just get through it. So what are some of those adaptations that animals have? Next. They're either physical or behavioral, and we're going to talk about a few of these, so let's keep going. All right, well, here's an activity, actually 2 of them in your guidebooks. They're called Size and Heat and Long Years and Heat. And basically the first one, Size and Heat, corresponds with Bergman's rule. So that basically says that there's similar species will have a larger body size in colder environments. Smaller ones in warmer regions. And larger animals have a lower surface area to volume ratio, so they radiate less body heat per unit of mass. And it's a pretty simple experiment to set up using larger and smaller containers of water and measuring temperature over time. Allen's rule talks about body shape. Body shape varies by climatic temperature by minimizing exposed surface area too, so particularly appendages. So here's the example of the Arctic fox versus the desert fox. The Arctic fox has smaller ears, a shorter, fluffier tail, shorter limbs, legs, in order to minimize that heat loss. And it also works the other way. It maximizes heat loss in hot climates. So take a look at those activities. I hope you enjoy them. Next. Okay, ecology card time. What is a small mammal with long front teeth for clipping twigs, has a short tail and long ears, lives in the forest, it eats buds and twigs, is eaten by the lynx? Great horned owls? Yes, snowshoe hare. Thanks, Shannon. Next. So, snowshoe hares, what kind of adaptation do they use to what helps them survive the winter? While you're thinking about that, you can type in your answers in the chat box. Hares have 2 to 3 litters with 4 to 6 leverets per year. They breed in mid-May. They turn white. Thanks, Russ. Okay, we can advance. So here's a photograph of a snowshoe hare. Ha ha ha. Can you find it? let's just take a few seconds to give everyone a chance to look for the snowshoe hare here. Maybe you can raise your hand. We won't call on you, but just so we know that you think you found it. Okay, next slide. Great. Did you find it, or can you see it now? Next slide. How about now? Oh, there's the little guy. Okay, next slide. There's our snowshoe hare. So really that white fur really does give it an advantage to hide from predators through the winter. Next. Who else turns white? Can you type in the chat box with some ideas? F says the urban. Me? Frosty eyelashes, yes. Me too.
Ptarmigan.
What was that, Kathy?
Ptarmigan and Arctic fox are up too.
Okay, excellent. All right, we can advance. Okay, one person got this one. Let's see if the rest can figure out what it is. Small fur-bearing mammal, sharp teeth. Turns white in the winter, eats voles, is eaten by great horned owls. What am I? The interesting fact is that it's nocturnal, but also hunts in the day. Just scroll down. The ermine. Good job, Beth. Okay, next. So the ermines, you can see the range, they're throughout Alaska. They're really widespread. And they turn from that reddish-brown summer phase to a pure white, but they do retain their little black tip of their tail. One theory that I've heard is that this might be used to confuse predators in the direction of travel, but they also display that delayed implantation. Okay, keep going. In your activity guide, you'll see two more. One's called, oh, here's the answer that some folks got, the ptarmigan and the Arctic fox. Very good. The color and heat loss and color and heat absorption are two, again, pretty simple experiments. They involve cooling water with ice and heating some water up and using different color containers, black or white, and you can easily put different colors, spray paint cans to perform this. You have a heat lamp that's useful in one of the activities. So simple, effective. Next. So some Arctic animals must maintain a difference in temperature of more than 180 degrees Fahrenheit, of course, between their body core temperature and their surrounding environment. And most mammals who live in Arctic, they wear two coats. The outer hairs are tough and coarse. They're water repellent, and they're known as guard hairs. And then the inner fur is soft and fluffy, and that hair traps the air around their body. And same goes for birds. Their soft inner downy layer traps air that's warmed by their body heat with the water repellent feathers on the outside. Next. And of course, there's blubber. Fat is very insulating. And a really fun activity that involves, if you don't have easy access to actual blubber, you can use Crisco and make these mitts. And you have directions to find out how to make it not so messy using a couple Ziploc bags. And you can experiment with what is warmer and take a vote among your class dipping your hands in a bucket of ice with a blubber mitt and a fur mitt on either hand. Okay. Okay, here's another physical adaptation, and here's the clue. This animal is a medium-sized mammal, and it has large feet, short tail, sharp teeth. Lives in early successional stage forests. And it eats the snowshoe hare. Oh, we all know by now. Can be eaten by great horned owls or wolverines. It's the only blank, yes, Shannon, it's the lynx, the only cat native to Alaska. Okay, next. Lynx they range from about 18 to 30 pounds. They mate in March, and they have 2 to 4 kittens that are born only 63 days later in a natural shelter, usually like a fallen tree. They are what's called digitigrade, which means they walk on their digits, their fingers. They don't use the whole pad. Ungulates are unguligrade, they walk on their toenails. A lynx is digitigrade, and humans and bears are plantigrade. They use their whole foot to walk. The lynx range is actually widespread, as you can see, all through Alaska and into Western Canada. Next. Here's some other animals in Alaska that wear snowshoes. Several northern animals have feet custom designed for walking on snow. Each follows the willow ptarmigan. It puts on a pair of snowshoes. Its middle toe actually becomes longer, and new feathers grow around all its toes. This feature reduces the pressure of its footsteps by more than 60%. The lynx, snowshoe hare, and caribou have comparatively large feet for their body size. The caribou grows extra hair inside its hooves for winter travel, and the snowshoe hare is known for its large feet. These special adaptations help to spread the animal's weight over a larger area so it doesn't sink into the snow. Next. So those are all physical characteristics. Now, what about behavioral characteristics? What animals do to stay warm? Well, snow provides vital insulation against extreme temperatures. So some mammals and birds make it through the winter by using the protection of the snow for thermal cover. Ptarmigan they roost in the snow by diving or shuffling in up to a foot deep. And then they tunnel away from the point of entry to confuse the predators a bit and conceal where their final destination was. And they'll sit overnight and sleep in there and defecate. And if you ever come across a photo like this on the right, or a situation like this in the snow, that's likely where a ptarmigan exited, and you can see its species in there. Voles, mice, shrews, lemmings, they all burrow under the snow and stay active during the winter. In regions that don't have permafrost, this subnivean zone, so the zone below the snow, maintains a temperature close to 32 degrees, regardless of the temperature above, once the snow is equal or greater than 6 inches deep. Also ringed seals. Fur seals, they have closed spaces under the snow and above the openings in the ice where they rest and sleep and give birth. And female polar bears den in snow caves. Okay. I believe this is the last activity in your guide that was emailed out. It's called Snow Blanket, and it involves putting liquid gelatin in film canisters and putting them one on the surface, and then you need a snowpack. So I don't know if this is going to work in Southeast right now. However, you would bury the canisters at different levels under the snow and time how long it takes for them to become solidified. Okay? All right, so if you have more questions, and I'm sorry we took up the whole hour without a lot of time left, but I want to point you to a few more resources. One is, well, go to this website that's included on your last slide, and I know you all have this slideshow at your disposal now, so you will find here all resources for teachers that Fish and Game provides, including what kind of education kits that we have for loan. And there's different kits in different regions of the state. And you can see what ones are in which offices. We have the curricula that I mentioned and that these lessons are pulled from, the Alaska Wildlife Curricula. And we have 5 books in total covering forests and tundra, wildlife for the future, our issues-based and problem-solving lessons, wetlands, what else? I might be missing a couple, but go ahead and take a look at what's available. If you have specific needs or a unit that's coming up that you need some help with, I'm always available to forward you some lesson plans. And this Wildlife Notebook series is available online. If you have specific questions about the life histories or descriptions and research on animals, this is a wonderful resource that covers just about every Alaska animal. There's also on our website, you can type in species profile of any particular species and learn about, again, the life histories and distribution and range and status. Finally, there's Wild Wonders magazines that are available by emailing our curricula coordinator, Brenda Doherty. And these are written to upper elementary level. I think they would be appropriate for middle school as well. The topics vary each year. The last edition was on forest succession and fires and how that's related to wildlife. And in the past we've had editions on wetlands and ungulates. So if that's of interest to you, you can also get on our email list for next year. Okay, next slide. And here's my contact information. So if you have further questions, please don't hesitate to send me an email or give me a call at any time, and I'd be happy to help you, whether it's with materials preparing for the Envirothon or a unit in your class, or if you have more questions about this presentation that I was not able to cover. That wraps it up for Wildlife Outside Your Door. And I really appreciate all of your attention. If there's any questions, I'm not sure how many more minutes we have. It is 5:03. Kathy?
Thank you very much, Sierra. I'd first like to thank Sierra for a very fun and interesting presentation. Kristen Romanoff has reminded us in chat that there's a curriculum search on ADF&G's website with the ability to search by state standards, by topic, or by grade level. It covers all of the Alaska Wildlife Curriculum book, Project Learning Tree, and Project Wild curricula as well. We will be, if you have questions, you can hang in for a while. If not, let me just wrap it up for those of you who need to go. We'll be meeting again in 2 weeks on Wednesday, March 4th at 4 p.m. The topic will be freshwater aquatics, and our speakers will be Josh Ashfine and Sabrina Larson with Alaska Pacific University. I'd like to pause for a moment and see if Meg Burgett, who is the instructor of record for the credit course, has anything she'd like to tell the students taking this for credit. But before I turn it over to her, I'd like to thank you all again for coming, and we'll talk to you in 2 weeks. Meg.